Alright, so now it's time to go ahead and hook up some line following sensors. And I've got a couple different types. One is this little red guy here that I buy from another source. I don't make these, but they're pretty nice. They work really well, actually. They're analog, which is one of the things I think is real important. There's a lot of different digital ones out there where you have to turn a pot and use a small screwdriver to set the value. But I really like to be able to see what's really happening and make logical decisions with my software. So this is an analog one. The other one is one that I actually make, which is pretty nice. I like it. It's a little brighter, has two LEDs that emit the infrared light, but it also has the feature where if you want to use it as a flame detector, you simply pull out this jumper and it essentially turns off the two IR LEDs, and all you have now is the IR phototransistor to work with. But it works great as a line follower as well, with that jumper on, and that turns on the LEDs. But in this case, I think I'm going to go ahead and use these guys here. There is one difference you have to be careful about, and it's a little hard to see, but if you look carefully, you'll see the signal. Let's see, you have to see it from this side. The signal power ground on this is flipped from this one. Okay, so in this case it goes signal power ground in logical order as it would be normally on, say, for example, a servo. On this one it goes signal ground power. Okay, so you're gonna have to be very careful when you plug this guy in. I don't know if you can see it if I zoom in. See that there's the powers on the outside. I had it. There we go. Power's on the outside, that VCC keeps fitting in and out. And then ground and then signal. Okay? So the last thing you're going to need are some male-female wires that we can plug this in with. And I'm going to go ahead now and hook this guy up. Like I said, you can see that VCC is on the outside, ground is in the middle. I'm going to choose to use a black one for, I'll separate these. I'm going to use a black one for the ground. In this case, I'm going to use a purple one for my signal. Actually, I'm going to go ahead and use a purple one for power. And I'm going to use a blue one for signal. Okay. It's sometimes useful to go ahead and plug these in before you actually try to get them underneath the chassis. Then you're also going to need a long screw, a spacer, probably a washer, and a nut, and these are going to get attached someplace down over here, wherever your preference is. I'm going to stick mine kind of about here. Okay, so I'm going to pause it, hook this up, and I'll be right back with you. Okay, so I've already hooked up one side. I've got this bolted down here nicely with the standoff and the nut on top, as you can see. And I have the power and ground hooked up to the bus. Okay, so the power and ground are here. And the signal pin, the white wire, is going to A0. Now these guys are analog, right? So they're going to need to use the analog side of the chip. Okay, it's going to have to be this side. So we fortunately have left this completely open, and we have plenty of room for more analog ports. But I haven't plugged this one in yet, and so I'll just show you what I did. So VCC, the power in is closest to me, and that one is the purple wire. Okay, so I'm going to plug it anywhere on the positive bus. The black wire is ground, so I'm going to plug it again anywhere on the ground bus. This wire actually has to go all the way across, and I'm going to go ahead and hook it into A1. So this is hooked to A0, this is hooked to A1. So now what we can do is write a little piece of test code, or actually we don't even have to write anything. What I'm going to do is I'm going to go to File, Examples, Basics, and just do Analog Read Serial. And then I like this, except for it's a little fast. Let's start with A0. Let's read what's happening here on this right sensor. So we'll leave it where it is. I don't like this 1 millisecond. It's a little fast. I'm going to go ahead and put that at 100 milliseconds. It's going to take 10 readings a second. I'm going to load this up. And then I'm going to open up the serial plotter so we can see it. And I have a business card with a black line on it so we can kind of see how it behaves. And it's taking a moment. Maybe I'll pause it. I'll pause it. Okay, so let's open up the serial plotter. You can do that a couple of ways. You can go to Tools and go to Serial Plotter, or you can just hit Control-Shift-L and that launches the plotter, and you can see we've got a value on it. So I'm going to take this white card and slide it underneath, and we're getting a lot of reflected light. But as I move it over to the black, you can see you get a very dramatic difference. Okay, white, black. So if I said, you know, if it's greater than, oh heavens, even if it's quite distant from the black line, anything greater than about 300, then you know that we're going to be on the black line. So we can use this then as our guide to steer our robot. So let me set up a little piece of code with that in mind, and we'll be back in a second here. Okay, so you can see I've added some lines of code to our running little piece here. I've added these two lines here, so I'm going to go ahead and define the right line sensor and the left line sensor as A0 and A1. Believe it or not, in setup you don't actually have to do anything when you're going to do an analog read. By default, it's going to figure out that the pin is going to be an input. You can make it an input if you want to here. It won't hurt anything, but it won't help anything either. It's going to trump it as soon as you call analog read. Now in my loop, okay, I've left these two things here. These are my bump sensors, if you recall. And all I did was add two more else-if conditions. I should tidy that a little bit. Okay, I've added two more else-if decisions here. And what it's going to do is it's going to analog read the right sensor. If the right sensor is greater than 300, well, we're going to put it in reverse for half a second. And then I'm going to turn right for a full 1 second. Okay, so it's going to be a pretty dramatic turn. And then I've done the exact same thing here as with the left sensor, and throw it in reverse, and I'm going to turn left for a full second. The default, if none of these are true, okay, if nothing gets the bump sensor and none of these things see a black line, the default is going to be, well, at the moment I've got it on stop. I'll open that up again. It's going to go forward for 5 milliseconds. Okay, we don't want to go very far. We want to be checking the sensors very, very frequently. You don't want to go, 100 milliseconds forward, in which case you've driven over the line. You want to check that very, very often. So if I load this up and see what we get, and as soon as it gets going, there we go. So now she's running, and we're going forward. And if I hit this line with my black line, okay, you can see that it sees the line, throws it in reverse, and turns. Same with this one. Okay, and then of course the bump sensors still work as originally planned. Okay, and you know what's odd is actually if you're going to do sumo, which is probably what you'd be doing with something like this. Right now we have it so if it bumps into something that it's going to, turn away from it. But probably if you're going to do sumo, let me go down here, you would actually want to make it turn toward it. So you probably want to make this a turn right, and this a turn left. And if we load that up, although you may not be able to see it with the video, but if it's moving along and it sees a robot here, it would then bump into it and attack it. Okay, and then if it sees the arena border, it would back up and try to get away. All right, so let me go ahead and put a stop to this. Uncomment this, comment that, and I'm going to make stop be the default, and I'll see you guys here very shortly.